So here we have a condition a plus b plus c equals to pi radians. We need to show that cosine squared a plus cosine squared b minus sine squared c, that's the same as negative 2 times the product of cosine a, cosine b and cosine c. Okay, let us begin. So we'll start our proof from the left hand side. So here we have cosine squared a added to cosine squared b minus sine squared c. Now we can easily combine the second and the third term because we have a standard formula. So whenever we have cosine squared alpha minus sine squared beta, now this can be also factorized to get cosine of alpha plus beta multiplied to cosine of alpha minus beta. Okay, so that means we will now have cosine squared a added to, so cosine squared b minus sine squared c, that's going to give us cosine of b plus c multiplied to cosine of the difference of the two angles, so that's b minus c. Okay, now let's do one thing. Let's transform cosine of b plus c. So we are going to use the fact that since a plus b plus c equals to pi radians, so we can say that b plus c equals to pi minus a. Now we take the cosine function on both sides to get cosine of b plus c equals to cosine of pi minus a. Now cosine of pi minus a, that's simply negative cosine of a. We're getting a negative sign because pi minus a means we are in the second quadrant where the cosine function is negative. So in other words, we have showed that cosine of b plus c, this is the same as negative cosine of a, provided a plus b plus c equals to pi radians. So now we will have the first term cosine squared a added to, now cosine of b plus c can be replaced with negative cosine of a multiplied to cosine of b minus c. Now as we can see on the right hand side we need the product of cosine a, cosine b and cosine c. So here what we can do, we can take cosine of a as the common factor from both of the two terms, so that takes care of the factor cosine of a, but we also need a negative sign. So what we'll do, we're going to take negative cosine of a as the common factor, which means that the second term will become positive. So we have cosine of b minus c, and the first term that becomes negative cosine of a. So this is going to be equals to negative cosine of a multiplied to, we have cosine of b minus c minus, now what we'll do, we'll transform cosine of a back to cosine of b plus c, but we need a negative sign as well, so this is going to be positive cosine of b plus c. Now what we have is the sum of two cosine function. Now we know that whenever we have cosine of alpha added to cosine of beta, that's is the same as 2 times cosine of alpha plus beta over 2 multiplied to cosine of alpha minus beta over 2. Okay, now what we have is negative 2 times cosine of angle A times cosine of, so b minus c added to b plus c, that's going to give us positive 2b, and we have division by 2, so that's going to give us b, and b minus c minus of b plus c divided by 2, that's going to give us cosine of negative c. Now cosine is an even function, so the negative sign won't be a problem here. So we simply get positive cosine of c, which is the expression on the right hand side. So here let's note it down. So here we have used the facts that cosine of negative theta, that's the same as positive cosine theta. So what we have done here, so here we have successfully showed that the left hand side equals to the right hand side, hence proved.